Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss a new chapter from chemistry. In the last week we have finished the second chapter, and that was nothing but is at matter around us pure. So first chapter was matter in our surroundings, second was is matter around us pure, and the third chapter in today's session onwards we are going to discuss, and that is nothing but atoms and molecules. Sorry. Yes, so this is the third chapter which we are going from today's session onwards. Atoms and molecules. And in today's class we are going to discuss the first topic from this chapter, and that is nothing but the laws of chemical combination. Laws of chemical combination. Before discussing the laws of chemical combinations, let me just introduce this chapter to you. Okay, so as we know, we have studied it already since class 5. That is everything around us is nothing but the matter, and that matter is made up of something, right? Now if we go on dividing that matter into smaller particles or smaller fragments in such a way that we are getting or we are dividing it in for infinite time, for an example you can say. So a certain stage will be there. After that certain stage we will not be able to divide that matter further into other particles, right? Small particles. So that certain stage is nothing but the atom, right? That certain stage is nothing but the atom. So in today's class we are going to discuss about the atom. Some examples I will give you. For an example, if we take the sugar, okay, the sugar which is nothing but the cane sugar which we use in our day-to-day life, then that sugar has the formula C6, just a minute, it is having the formula C12H11 C6H22O11. Okay, so that is the formula for the sugar. Just a minute. Yes, instead of cane sugar I will take a different example. There is a reason for that. I'll explain it later. So we are going to take another example, and that is nothing but glucose. Okay, glucose is the sugar, the simplest form of the carbohydrate we know, which is present in Glucon-D and other energy drinks. So its formula is C6H12O6. Okay, now this is made up of three types of atoms. One is carbon, C for carbon, then other is H for hydrogen, and third one is O for oxygen, right? That means this is made up of these three atoms, that is carbon, hydrogen and oxygen, right? So if I take the glucose powder and if I go on dividing it into the different fragments, so after a certain stage I will get the atoms from it, right? I will get the atoms from it. Further atoms, like if I go on dividing the atoms further, that is not possible, or further we cannot divide it very easily. Therefore we can call it as indivisible, right? We can call the atoms as indivisible, right? So what are atoms? Atoms are nothing but the smallest fundamental particle of any matter, right? Therefore I will write down the definition: smallest fundamental. Previously it was considered to be the indivisible in nature, but later on when more research was there on this particular atoms and molecules topic, later on scientists found that atoms also can be divided, but that is very recent discovery. We are not going into that part. That part you will discuss in the, or you will study that part in the class 10. Right now just remember this definition: smallest fundamental, indivisible, indivisible particle of any matter is nothing but the atom, is known as atom. Okay, then what about molecule? Different atoms, okay, atoms combine with each other to form molecule, right, to form molecule. That means here C6H12O6 is a molecule, single molecule, whereas the glucose powder, if I am talking about glucose powder, okay, that glucose powder is nothing but the compound, right, that glucose powder will be compound, right. Okay, so glucose will be converted to molecule will be converted to atom, divided into atom, right. So that part also I will write down. And molecules combine to form a compound, right. Okay, yes, so about this thing we are going to discuss. Like in ancient areas also, like before 500 years ago or before 1000 years ago, 2000 years ago, likewise very ancient era, at that time also the so many scientists were working on the atoms and molecules, right. There were some Indian scientists as well who were working on, or who has discovered some important things related to atom. Some of their names I will write down. So first name is Maharishi Kanath. Yes, so why he is important? He is very important. He was an Indian philosopher who postulated that if we can go on dividing the matter, he gave the matter was nothing but the padartha in Sanskrit. We shall get a smaller and smaller particles. Ultimately, we will end up with the smallest of all, smallest of particle, and that we cannot divide further. That is nothing but the atom. But Maharishi Kanath called the atom as Paramanu. Okay, Paramanu, the Sanskrit word for atom. Okay, so like what he postulated, in short I will write down. So padartha, that is nothing but matter. Okay, matter divided into the Paramanu, Paramanu. Paramanu is nothing but the atom. So that was postulated by Maharishi Kanath. Okay, then next scientist is again an Indian philosopher only, and name is Pakudha Katyayama. Okay, what he told us, that is these Paramanu, they are continuously undergoing process to form the padartha in nature. Okay, then after this, apart from Indian philosophers, some other scientists also were working on it. So one Greek philosopher, we need to only remember these names. Okay, no one will ask questions on this. The Greek philosophers, Democritus, and Leucippus. Okay, they also gave the same thing. Then they give the name atom to the Paramanu. Okay, they give the name atom to the Paramanu. Then after this, the next scientist is Antoine Lavoisier. Okay, what he has done, he has given the two laws of chemical combination. He has given the two laws of chemical combination. Two laws of chemical combination. Okay, yes, so these are some important or introductory part related to the laws of chemical combination. You can just take a screenshot of this page first of all, and then we will discuss the actual laws of chemical combination one by one. One more scientist name you can write down here. So, along with Antoine Lavoisier and Joseph L. Proust. Yes, now take a screenshot. Okay, I hope you have taken a screenshot. Now let us see the laws of chemical combination one by one. So here, first of all, I'm just going to write down the names of these two laws of chemical combination, and then we are going to discuss it one by one. So first law is called as law of conservation of mass. And the second law is law of constant proportions. Law of constant proportions. Okay, so these are the two laws. First of all, let us discuss the first one, and that is nothing but law of conservation of mass. law of conservation of mass. Okay, what is this law? I will write down the statement first of all. Mass can neither be created nor be destroyed in a chemical reaction. So this is a statement for law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction. What is the meaning of it? Let us see the meaning of this reaction or meaning of this statement. So here, for understanding purpose, I am just going to take some examples. If I react the NaCl, that is nothing but the sodium chloride, okay, that is nothing but the sodium chloride, plus, or simple reaction we will take instead of this reaction also I will explain, but before that let me just take the simple reaction, and that is nothing but, if I take H2, that is hydrogen gas, if I combine it with O2, that is oxygen gas, and I will get H2O. H2, that is water, right? So here the balancing is like this, right? Okay, so here if I observe this reaction, in this reaction, for an example, if I am taking, just give me a minute, let me see if I can upload the image or not. Yes, I'll write it down on the page only. Okay, yes, so what is this balanced equation says? This balanced equation says that in this reaction 2 molecules of hydrogen are required. Okay, so instead of 2 molecules I will write down 2 moles. What is the meaning of moles and all? I will explain later on in the same chapter. Okay, 2 1 2, right? So this is the ratio. So 2 moles of hydrogen are required, 1 mole of oxygen is required, and 2 moles of water are produced by this reaction. I will repeat. This reaction says, during this reaction, how many H2 molecules are required? 2 molecules are required, 1 molecule of O2 is required, and 2 molecules of water are produced in this reaction. Instead of molecules, I have used the word mole. What is the meaning of this word mole? M-O-L-E. We are going to discuss in the same chapter later on. Right now you can just consider this mole is nothing but the molecules only. Okay, yes. Now every atom is having the atomic weight, that is weight of atom. Similarly, every molecule also has the molecular weight, right? How to find out the weight of those molecules? Let us see. So first of all, let us see the weight of H2 molecule, which will be called as molecular weight of H2. Okay, molecular weight of H2, right? H2. Let us see how to calculate. As we know, the atomic weight of H2 is, every atom has a weight, right? A hydrogen atom also has a weight. Atomic weight or atomic mass or mass number, right? These three are same thing. Atomic weight of hydrogen atom is equal to 1, right? It is equal to 1 gram, right? We know that that is fixed number. Therefore, what will be the MW? MW stands for molecular weight. Molecular weight of H2 will be equal to, how many hydrogen atoms are present in H2 molecule? 2. 2 multiplied by atomic weight of hydrogen, right? 2 multiplied by atomic weight of hydrogen. Okay, that will be equal to 2 into 1, that is equal to 2 gram, right? So how many, what is the weight of H2 molecule? It is equal to 2 gram. Okay, that is the weight of one H2 molecule. But how many H2 molecules we have used here? 2, right? Therefore for 2 moles the weight will be equal to 2 multiplied by 2 equal to 4 grams, right? Do you understand that? Why we are multiplied here by 2? Because how many molecules are required for reaction? 2, double. So double I have written. Then let me write down about the oxygen molecule, right? Okay, let us see how to find out the molecular weight of oxygen molecule. Okay, as we know, atomic weight of oxygen, okay, that is also a fixed number. Oxygen atom is equal to, one oxygen atom atomic weight is 16 gram. Okay, yes, so it is equal to 16 gram, right? Therefore what will be the molecular weight of oxygen? Molecular weight of O2 molecule will be equal to 2 multiplied by 16, because there are 2 oxygen atoms in it, right? So that is equal to 32 gram. Okay, so here I will write down 32, only one of O2 molecule is used, so no need to multiply it by anything. So 32 gram of oxygen is used in this reaction. What is the meaning of this? That is, when we try to, or when we are doing this reaction, we are going to do the reaction in between 4 gram of H2 and 32 gram of O2. Okay, I will repeat. This reaction is performed in between 4 gram of H2 and 32 gram of O2, right? Okay, after mixing, let us see how many grams of H2O are produced. Okay, how many grams of H2O are produced. For that purpose I need to find out the molecular weight of water also, right? As we know, atomic weight of hydrogen and oxygen I have already written, so therefore I will write it down directly. Molecular weight of water is equal to, there are how many hydrogen atoms? 2 multiplied by atomic weight of hydrogen, right? This is one part, plus apart from that there is one oxygen also, so 1 multiplied by atomic weight of oxygen, right? Okay, let us do that. 2 multiplied by 1 for hydrogen plus 1 multiplied by 16 for oxygen, so it is equal to 2 plus 16, that is equal to 18, right? 2 plus 16 is equal to 18. So what is the molecular weight of H2O molecule? 18 gram, right? How many moles are produced? 2. So we have to multiply the 18 by 2. Okay, so let us do that. Therefore 2 multiplied by 18 is equal to 36 gram, right? 36 grams of water molecules are produced, right? What is the meaning of this? I will just write down it again here at the bottom. What is the meaning of this? We have taken 4 gram of H2, we have combined it with 32 gram of O2, okay, 32 gram of O2, and we got total 36 gram of water, right? 36 gram of water, right? That means during this reaction, if you see the sum of these masses, okay, sum of mass or sum of total masses is equal to of reactants, right? Left hand side is the reactants. Reactants is equal to 4 plus 32, that is equal to 36 grams, and here only one is produced, therefore 36 gram of products, right? So you can see the mass of reactant used and mass of the product formed is exactly same, right? Mass of the reactant used and mass of the product form is exactly same. That means the mass is conserved, right? The mass is conserved, right? That means during this reaction, during the course of this reaction, the mass is conserved. Okay, just a minute, right? 36 gram of reactant and the of product are formed. That means mass is conserved. The 36 grams are out of 36, not a single gram of mass is not wasted, right? All the 36 grams are conserved in the product. Conserved means what? Nothing is wasted. Do you understand? This is called as law of conservation of mass. Not only for this reaction, you can do one thing after the class. You can just take any example of any reaction. Okay, then calculate the masses like this and then see in the product what is the mass obtained. Okay, you will see that mass can neither be created nor be destroyed in any chemical reaction in world, in nature. Okay, to understand, take a screenshot of this page first of all. I hope you have taken a screenshot. Now let us see the second law, that is law of constant proportion. This is also very easy to understand. Yes, we are going to discuss the second law, and that is law of constant proportions. Law of constant proportions. Okay, to discuss this law, first of all I will give you a simple example. Okay, now I am going to do one experiment. I am going to take the water samples from different sources, right? I am going to take the water samples. First sample I will take, just a minute, I will take this one. This is the first vessel, this is the second vessel, and this is the third vessel. Okay, now in these three vessels I am going to take the water sample from different sources, right? This is the first, the second vessel, and this is the third vessel, right? Okay, I am going to take the water from different sources. So first one, let us say this is the rainwater. Okay, first one, let us say this is the rainwater. Okay, second one, let us say this is the distilled water. Okay, distilled water which is obtained after the distillation process. You know the distillation process very well. Okay, distilled water. Then third one, let us say for an example, it is the water from any water resource. Let us say water from river. Okay, so it is a river water obtained from river, right? Now if I study these three samples of water, if I find out their structure, right, structure of the water present in them, right? For rainwater it will be H2O, for distilled water also it will be H2O, for river water also will be H2O. Does not matter from what the source you are getting the water, from what is the source from which you are getting that water, its formula will remain as it is, right? Its formula will remain as it is. Its formula will never change. Its formula will never change means what? If I find out the ratio of hydrogen as to oxygen in them, right? So if I say for all of them the hydrogen as to oxygen ratio is 2:1, right? So this ratio is, the ratio remains constant. Ratio remains constant. Ratio of atoms, okay, ratio remains constant in all the three samples of water. In all the three samples of water, irrespective of the source from which they are obtained. Okay, so this is nothing but the law of constant proportion. Does not matter from what source you are taking that water, its formula always will be H2O, right? Even if it is the sea water, that is also H2O. Whatever may be the source, its formula will never change. It will be H2O only. There will be always 2 hydrogen and 1 oxygen, right? This is called as law of constant proportion. Proportion of hydrogen as to oxygen in water sample from all the sources in nature will never change. It will be as it is, right? Law of constant proportion. Now this is not only, but you will say then how the taste is different, like rainwater is different, distilled water does not have any taste, river water is different, sea water is different. So these tastes are not due to water, these tastes are due to the additional component present in the water, right? Like minerals, other chemical substances, or so many salts are present in the sea water. Due to these other additional substances, the water from the different sources having different taste. But what is the formula for water in them? It is always H2O. It will never change. Okay? This is not only true for water. This law is applicable for all different types of the substances. Okay, I'll give you one more example. There are different forms of sugar. For example, you can say white sugar, white crystalline sugar. Okay, crystalline sugar, the crystal sugar. Okay, then next I'll take the brown sugar. Okay, then next I'll take the powdered sugar. Okay, powdered sugar, right? Okay, now these three are different physical forms of sugar, right? These three are different physical forms of sugar. Okay, but now if I find out the formula, okay, if I find out the chemical formula of all these sugars, right? In all of them, the formula always will be the same. It will always be constant, and the formula is, okay, chemical formula is C12H22O11. Okay, here also it will be C12H22O11. Here also it will be C12H22O11, right? That means the proportion of carbon as to hydrogen as to oxygen will never change whatever may be the source of the sugar, right? Okay, do you understand? So this is called as law of constant proportion. The proportion of atoms of element present in any molecule will never change, does not matter what is the source from which they are obtained. So these are the two laws which we have discussed today. First one was law of conservation of mass. Here also you can check this law by using whatever may be the example. I have taken the simple example. You can try with some other reactions also. Okay, then will never get an anomaly in this. The mass is neither created and nor destroyed in any chemical reaction. Mass of the reactant and products always will be same. And then law of constant proportion, whatever may be the source of that compound obtained from, but its formula will be always same. Formula means what? The proportion, the ratio of atoms present in it. Okay, so that's all for today. Finally, you can just take a screenshot of this page, law of constant proportions, and then we will end here. I hope you have taken a screenshot. Before ending the class, let me just show you the daily practice problems, that is DPP. So this is a teacher's portal. Similarly, your portal will look. You have to go to resources. Then on the left hand side, you have to go to writing materials, where we can see DPP, daily practice problem. You have to go to DPP, then click on the DPP. You can download that here, and you will be able to see the questions. You are going to download the question. You are going to solve the question. Write down the solutions on your notebook or any paper. Take a picture of that paper, and you are going to upload it just like you upload any image on social media. Okay, so that's all for today. Thank you so much for your precious time, students, and all the very best to you. Thank you.